Hello and welcome back to episode 300 of Friday Minis. My goodness, I've been doing this for 6 years. Anyway, our topic at hand today is asynchronicity. Now, this is a very interesting topic because, well, being able to do things at the same time, or should I say at the same time, is an interesting thought, right? It makes our programs even more powerful than, a normal serialized program. But what is async? What isn't async? That's an important point to think about. So let's start off by talking about parallel computing. You generally know what that means, right? There are two things that are happening at the same time in parallel. In our modern day, with our multi-core processors, we can actually have, things happen at the same time in parallel, right? One task happening in each core. However, async is not that. Async is not generally a replacement for parallel computing or multi-threading of any kind. So that is the important thing you need to take away when you're going into async, whether you're talking about JavaScript or Python or any other languages that support this. Of course, the vocabulary may be different from language to language, so do be careful about that as well. So then, what is async? Simply, async is like the earliest form of multitasking, where you have multiple coroutines that share the processor time. Essentially, you have everything in one thread, and what these coroutines are doing is they're yielding to each other. What yielding means is, I'll do my task, and then if I need to wait or whatever, I'll give up my time to someone else who can then make use of the time, right? Rather than me sitting there and busy waiting, holding up the other tasks that need to be done. That is the idea. Async is about time sharing, not about multi-threading. So, in fact, if you are just looking for the theory, that's it. But let's go and get our hands dirty and just look at a very simple Python example of async. Now, fair warning, this doesn't look like normal Python because, async is not something we do on a day-to-day basis. But it is very useful, so it's worth knowing it in greater detail. Let's take a look. Before we implement any form of asynchronicity, let's just set the scene first. Here we have two functions, A and B. Each one does something, sleeps for a while, does something else, sleeps for a while, so both of these functions take some time to complete. If we call it normally like that, then of course that effect is sequential. Everything from A needs to run to completion before B even begins. So that's, the normal way, right? Everything is sequential, one after another. Of course, we are wasting time because while we are waiting, between the iterations of A, we're not really doing anything meaningful, right? We're just sitting there twiddling our thumbs. So let's try and make it a little bit more efficient. Our second demo here introduces Async Boilerplates into the code itself. So, alright, lots of things going on here. Let's take a look at each little thing. First and foremost, we import async IO. Now, this Python library is designed for IO, hence the name, right? Input and output. But it has features that can be used for, just async in general. So I think it's a very good thing to have. Moving on into the definitions themselves, our functions are now classed as asynchronous functions. We use the async keyword. We also have await. That means wait for this guy to, give me a value, right? So this is where you can wait in an elegant manner. Finally, we also have our main function, which contains the gather function call. Now, this isn't the only way to use async in Python. In fact, there are tons of different ways. But this is the simplest, right? And we want to keep things simpler here. So what gather means is just do A and B at the same time. At the same time, of course, doing the whole yielding thing. So let us go ahead and run our code, and that doesn't look quite right. A and B are still being sequential. So what went wrong? You see, the issue is with time.sleep. When we tell it to do that, it, just sleeps, right? It just basically does a busy wait, does the whole twiddling of thumbs thing. It does not actually yield. It does not actually give up the processor time to another coroutine function. As a result, we get the same sequential effect. So moving on to our third demo, all we do is we replace the time.sleep statements with a proper sleep, one that actually knows how to yield. And that will be async IO's version of sleep. We await for it to happen, right? And look at the result. Right away, by changing those two statements, A and B are now interspersed with each other. These two functions can now yield to each other, and as a result of that, it appears that they're running simultaneously. So there you go, just a very simple toy example of async in action. Remember, the key important thing you need to note is that, well, it's about the coroutines yielding to each other. It's about coroutines saying, well, I'm not going to do anything right now, so do you want to do something? And then they yield to each other like that. Anyway, that's it. That's all there is for this particular episode of Friday Minis. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.